Hey guys, welcome to Crown Smart. In this video we want to solve this nice proposition. Okay, the proposition says that let D be a class of sets which is not necessarily an algebra. So D is a class which is not necessarily an algebra. Then the smallest unique algebra containing D is the intersection of those algebra containing D. So the smallest unique algebra containing D is the intersection of those algebras containing D. So if we have a family of algebras containing D, then the smallest unique algebras containing D is the intersection of it. So we are going to show that the smallest algebra containing the intersection, and we are going to show that that intersection of those algebra is what is unique. So let's begin. Let's show the proof. Okay, now to see this, let's this be a family of let this be a family of algebras containing let it be a family of algebra containing D. So let this be a family of algebra containing what? Containing D. So if this is a family of algebra containing D, that is for every D in the index set, D is a subset of this algebra containing D. Okay, so if we say let this be the family of all algebras containing D, now for this to be a family of algebra containing D, it means that for any D I pick in the index set, that D must be a subset of what? This algebra. So D is a subset of any algebra coming from what? This family. Now we all know that if this is a family of algebra, then its arbitrary intersection is also what? An algebra. From my previous video, I showed that arbitrary intersection of family of algebra is what? An algebra. So we all know that we all know that arbitrary intersection of algebra is an algebra. Okay, so we know that the arbitrary intersection of this family will still form what? An algebra. Now let's check if this arbitrary intersection of an algebra contains what? D. Okay, now also observe that since for every D in the index set, D is a subset of this algebra containing D. Okay, we can easily see that D is a subset of what? The intersection of what? This algebra. Okay, so observe that since for every D in the index set, that D is a subset of this algebra. Okay, so since for every D in the index set that D is a subset of this algebra, which is what we wrote here, we can easily see that D is a subset of what? This intersection. A simple way of viewing this, do intersection of both sides. If we do intersection of both sides, intersection of D will still be D. Okay, now intersection of this algebra where D is running from the index set will be this. Okay, now so since we see that D is a subset of this, so we can now conclude that this is an algebra containing what? D. So the arbitrary intersection of this algebra where D is coming from this is an algebra containing what? Containing D. Okay, so this is an algebra containing what? D. Next, now observe that whenever we have intersection of algebra, the intersection of algebra D in this is a subset of this. Observe that this intersection is a subset of this. Okay, for example, if I say we have A1 intersect A2, observe that A1 intersect A2 is a subset of A1 and it is also a subset of what? A2. So this is a subset of A1 and this is also a subset of A2. Okay, so A1 intersect A2 is also a subset of A2, meaning that it is the smallest of these both. Okay, so meaning that this is the smallest because the intersection of all those family forms the smallest set, and that smallest set is a subset of any of those family, which means that this is a subset of what? This. So this implies that D is a subset of what? This arbitrary intersection, and this is a subset of what? This. So we have shown that this is the smallest algebra containing what? D. Meaning that if this is an algebra containing D, okay, then this is the smallest algebra containing D, because it is. Why is it the smallest? Because it is a subset of this. Because it is a subset of this, it is smaller than this, and it also contains what? D. So this we have shown that this intersection is the smallest algebra containing what? D. Now next we need to show that it is what? It is unique. Now to show that something is unique, for us to show that something is unique, we have to assume that there exists another algebra containing D, which is the what? The smallest. And then we now show that that algebra is equal to what? This intersection. Once we are able to achieve that, we have shown that this is what? Unique. So now suppose I'm coming, give me a minute. Now suppose there is another algebra. Suppose there is another, please pardon my handwriting, just follow my voice, okay? Suppose there is another algebra. Suppose there is another algebra, say A star, okay, such that D is a subset of that A star, and A star is a subset of this intersection. Now what this means is, suppose there is another algebra, say A star, such that D is a subset of this A star and A star is a subset of this. What this means is that suppose there is another algebra that contains D, that's what it means, and this algebra is the smallest. Remember we said that this was the smallest initially, right? So if there's anything smaller than this, then this is what? The smallest. So suppose there is another algebra containing D and it is what? The smallest. Now if we can now show that this algebra is equal to this, then we are done. Then we have shown that this is what? Unique. Okay, so now let's see if we can show that it is unique. Now since this is an algebra containing D, what does this mean? Now since D is a subset of this algebra, this implies that this algebra is in what? It's coming from the family. It's coming from the family of algebra containing D. Since D is a subset of this algebra, this implies that this is coming from the family of algebra containing what? D. Because for this algebra to contain D, then it must be in the family of algebras containing what? D. Okay, and so this also, and if this is coming from the algebra if this is coming from the family of algebra containing D, this implies that the arbitrary intersection of this family containing D is a subset of this. This implies that this arbitrary intersection is a subset of this, because if we take the intersection of all the families of algebra containing D, you see that the intersection is the smallest, right? So it is smaller than every other algebra coming from this family. So meaning that this intersection is smaller than this, since this is coming from this family, right? So the intersection of this algebra will be the smallest. It is to be smaller than any algebra coming from what? This family, because we say that if this is coming from this family, when you now do the intersection of all those algebras coming from this family, the intersection is the smallest of them all. So this is smaller than this. That's what it means. Now if this is smaller than this, now remember, but from our assumption that A star is a subset of what? This intersection, right? From our assumption that A star is a subset of this, okay, so this implies that A star is a subset of this intersection, okay, and this intersection is a subset of A star. Remember, we said that this implies that this is a subset of this, but from our assumption, because we are from our assumption that this is a subset of this, right? So, but this is a subset of this, right? So this implies that this is a subset of this, and this is also a subset of this from here, right? Now, from here now, we can now conclude that what? That A star is equal to what? The intersection. Okay, so this is a subset of this, and this is also a subset of this. What does this mean? It means that this is equal to this, a set. When we say that a set A is equal to B, what does it mean? That A must be a subset of B, and B must be a subset of what? A. So A is a subset of B, and B is a subset of what? A. Once this is true, then it means that the set A is equal to what? B. So once we have this is a subset of this, and this is a subset of this, then we can conclude that this is equal to this. Now, we have now shown that given any, suppose there is another or any algebra, okay, containing D and is the smallest, that algebra is the what? Is this intersection. So we have definitely shown that this is what? Unique. So therefore, from our proposition, we have shown that any smallest unique algebra containing D is actually the intersection of those algebras containing what? D. So thank you very much for watching this video. I hope you understood what I just did, and also please do not forget to like and subscribe. Share to your friends. Thank you very much.